myfavoritepodcasters.jpg, which, if you open it in an image viewer, is most likely a picture of Matt and Mike. Hey, Matt.
Hey, Mike.
Would you like to do a podcast?
I would indeed.
Then let's do it. Hello, and welcome to Hacking the Grepson, where we talk about programming and development and coding and such. And I believe that you cannot have a programming podcast without an episode like the one that we plan to do today, which we are titling Data Types and Structures. Isn't that exciting, Matt? Don't data types and structures just get your mind racing?
I mean, in and of themselves, no, but actually one of my favorite computer science classes in college was titled, I think it was Data Structures and Algorithms, but yeah, basically the same idea.
Yeah! I love talking about how data is typed and structured. So let's talk about that.
I mean, Brent Spiner is my favorite actor on Next Generation, so... And Picard.
I'm more of a lore guy. Just kidding. No one's a
Same
lore
actor.
guy. That doesn't
Same
make any
actor.
sense. No. Are you kidding? Okay. So, data types and structure. So what do we mean by that? Well, let's just get down to brass tacks. Okay. Programming, coding, basically you're trying to tell a computer what to do. And one thing that's very foundational to that is the concept of a variable. Now, I wrote in this outline of mine that a variable is a name for data at a location in memory. Does that sound like a variable to you, or do you have a different definition for that, Matt?
That is how I would define it, more or less. What's interesting is the word variable has meaning in English, and there are variables that are not variable. There are constant variables. So
there are.
We are talking not about the concept of variability. We are very much going to stick to the variable is an alias, basically. It's a human readable alias for some chunk of data that sits somewhere in the memory of your computer.
Right. For example, load up a browser, Chrome, which is the one I'm looking at right now. It probably has a lot of variables that point to a lot of data in memory. So like when you start up the program, the memory in your computer, the RAM, gets loaded with a bunch of information that Chrome needs to reference and change as you browse the web. As you said, it's an alias. It's basically for us humans. I mean, you could just say, you could say everything in binary, which at the end, the computer is just reading a bunch of zeros and ones. But when you're writing
say the memory addresses for everything.
Right. We could just say the memory address. That would be not very efficient in this day and age to write your code that way. So instead, we have these things called variables. I mean, I assume they're called variables because they can point to different things, and those things can change, but the alias doesn't. Does that sound right to you?
More or less. I mean, I think it probably comes from back in the old assembly days where you had registers, which were basically memory locations where you could set data and change it out. And so those probably got called variables because what's in register 1 might change. But I think if people are not familiar with variables, welcome to this podcast. You've probably been very confused for the last 40-something episodes as we talked about all sorts of other stuff. But, it's not an intuitive concept, but I think something that is equivalent basically is file names, right? File name is the human readable name that we give to the address space on your hard drive, right? But most people just there's a file and it's called this, right? And that it's an alias, it's a variable that just in a slightly different context,
right? It's like you have myfavoritepodcasters.jpg, which, if you open it in an image viewer, is most likely a picture of Matt and Mike. But that My Favorite Podcasters part and the .jpeg is just the human readable thing pointing to a bunch of data on your hard drive, most likely, that is the image of us. or,
Indeed.
who, yeah. Obviously, a variable is a very crucial part to writing any program because essentially you're trying to tell the computer what to do, and you need to organize all of the data that you're working with, that you're either reading from or that you're changing and displaying to the user for whatever your program is going to do. Now, there's not obviously, just as variables can change the data that they point to or that they reference, there is there are many different kinds of variables, and I tried to group them into two major categories. That being basic slash sometimes they're called primitive variable types, and then what I'm just going to call complex. I didn't really necessarily see a specific universally accepted term for things that are not primitive, but that's just what I'm calling them. And then each of those
Advanced.
groups, advanced, there you go. A basic variable and an advanced variable. Now, I was hoping maybe Matt, you and I could trade off on some of the basic slash primitive ones and kind of give our take on what they are and maybe like some examples of why you might use one of them. So why don't you start us off?
All right. One of the most basic variable types, although it doesn't actually exist in a lot of the earlier languages, is the concept of a Boolean, right?
Mm-hmm.
And that's basically just a binary value. It's true or it's false. And
Mm-hmm.
at its most basic, that is all it can have. It can either be store true or it can store false. And the way that is usually and hopefully always represented behind the scenes is as a one or a zero, right? This bit is on,
Mm-hmm.
this bit is off. It's kind of the most fundamental concept,
Mm-hmm.
because everything else is built on top of those. Um, there's also Boolean logic that you can apply to things, like this and that,
Mm-hmm.
and that. So there's a lot of variables that, depending on what's in them, can be interpreted as a Boolean. For example, is this thing null or undefined versus is it not? The null and undefined, that's not necessarily a Boolean, but it can be treated as one. Most variables in most programming languages have the ability to be interpreted as a Boolean.
Right. I think at least in web programming, but really in any kind of programming, booleans are often used as flags
Mm-hmm.
to denote the status of something. Like if you have a particular, like if you have a checkbox on a form, is it checked or not? That
Yeah.
is checked is a very popular one. Or light and dark mode. Like whether one is triggered or the other one is triggered, and you can toggle between them. But yeah, I think like down in the end, basically it's just like, is this a on bit or is it an off bit? And it's about as simple as you can get as a variable. It's just saying, holding a value of like whether this was true or not in memory. So
Yeah. The
it's very
a fun
useful.
thing a fun thing with booleans and naming is every once in a while in programming you'll stumble across somebody who named their variable like backwards, basically, where they're like
Mm,
not checked, to
mm-hmm.
use your example, and then so not checked is true, then I'm not then clear this and so name your variables correctly, kids.
you know, I feel you on that one, and I assume the reason that happens is because of default states,
Yeah.
where if you assume that the default state is off, then you're going to create a boolean variable name that's like is something. But if the default is on and the alternative state is off, then you might do not checked or something. But I think the important part when you're writing a program, especially not just for your own sanity, but also if you ever have someone else work on it, is to just be consistent. For Pete's sake, keep them all is checked, hopefully. But if you have to go not, then make them all not checked, but don't mix them, because that that is much harder too. Because we have a flow state, and we have assumptions about things, and so you have to agree on one way or the other. And I think the agreed upon one is that default is off, and the alternative is turning it on, but maybe not always. So anyway,
Yeah. It just gets fun when you start putting like Boolean operations not checked to mean anyway.
yeah. Or if you name your variables like Dave, but it's Boolean, and then you're just an evil person.
Dave is true.
Um, yeah. Okay, so the second one I have in here is number, and that is a variable that just has a single numerical value, and generally that's either an integer, so a 1, 2, 3, 4, but it could also be -1, -2, -3, depending on whether the variable is signed or not. Signed referring to the negative sign or not. And then it could also be 0. And then the other kind is floating point, or just float, and that's anything that's like 1.5, 4.004. I think it might be in just JavaScript, but it might be, maybe it's computers in general, that like no matter what kind of number you put into a variable, the computer is always representing it as a float, or it's the other way around, or I forget how that works,
No.
but I know there's a lot of complexity in like floating point arithmetic. Like computers have had like their own hardware piece that just does that because it's so computationally intensive compared to adding and subtracting integers. I don't know. Can you expose some more light on that?
When I was coming up in computers, so this could have changed somewhat in the last 20, 30 years, the way floating point numbers were generally represented was the same way that we would represent an integer, but it was at two integers, and you had one that was like the values and one that was basically like the exponent, right? Like where into that, where's the decimal point, effectively. So it's like, all right, I've got, my number is 42, so it's 101010, because that happens to be the binary for 42, which is one of the only ones I know off the top of my head.
I love that. That's great.
And then, but if you want to do 4.2, you might have that, and then the other part of the floating point number would indicate that, it's, there's one digit after the decimal point, or whatever, right? Or one digit before, more likely. And then it's 4.2. Yeah. What's as we're talking about variables in general, something to note is that they are just locations in memory, and what the variable type is telling you is how to interpret, how many bytes of data to look at, and how to interpret that data, right? So you could represent all of these in a gigabyte of data. It would be stupid for a Boolean, since you only need one bit. And for floating point, you can that's where like you get floating point precision issues. You might remember like when Intel was Pentium processors, that was the one, right? There was some issue there, and it has to do with just how floating point is represented. There's some numbers that are not easily represented as whole numbers, even though we might think of them that way. If you're try to break them down into powers of 2, and then with the floating point and the exponent, it's easy for them to get muddled.
Yes. Still a very important thing, because numbers are used a fair amount in coding, and I don't know where we would be if we didn't have the ability to save a specific number as a variable. So I think that's pretty important. Now,
And
of course... Oh, sorry, go ahead.
I was going to say, most, like, if you go to early programming like C, most variables are effectively stored as numbers. And it's just how you interpret it. Oh,
Right.
This thing is, it can be an int. But because everything goes back to memory address, which there's variables for in and of themselves. Then, like, that's the next one we could talk about is pointers.
I would love for you to take this, because I remember learning C back in 1999 for the first time, and trying to grok the idea of a pointer variable. And then, like, I got into web programming and basically never touched them again. So I think you're more of an authority on this one. So why don't you take that one?
Yeah. Most programming languages these days, you just don't have to worry about pointers, which is honestly really nice. Effectively, what a pointer is it is a variable that holds a value that represents the memory location for the data that you want to look at, right? So if my data is at memory address 100, my pointer variable, its value is 100.
Mm-hmm.
And if I change my pointer, I am no longer pointing at the value that's in 100. So if the value that's in memory address 100 is my name, it's Matt, right? And I change my pointer value by 1, now it's at, right?
Mm-hmm.
um, and most I don't think it was ever explained very well to most people. Like they didn't explain it the way I just did. Whereas like you've got two variables basically. You can have a variable and a pointer to that variable. And the variable is it's hey, go here in memory and interpret it this way. And a pointer variable says go here in memory and interpret it this way. And that way to interpret it is a number or a hex string that it's a memory address. It is the way
Right.
that memory addresses are stored. And then there's this whole thing about dereferencing and
Mm-hmm.
which is just how you get from one to the other, really. Like, give me
Right.
the address or go to the location that is pointed at by this thing.
Yeah, I feel like the kind of programming that I was doing when I was just learning C, like learning what a pointer was and using a pointer, it was mainly just to use a pointer, but there
Mhm.
was no real practical reason that I needed to use a pointer for the kinds of things that I might make at that level, like at that beginner level of C, for example. I mean, I'm not even sure what I would want to make in C as a beginner beyond like maybe a command line thing that like plays guess the number or tic-tac-toe or something. And I just never really understood why I would need to know the memory address of something, let alone do something to that memory address.
The main place I've encountered it in my career has been around bit packing, right? I want to make a structure in memory that looks a very precise way. I want these
Mm,
4 bytes to mean this thing, and then the next byte is this, and then the next 6 are this, and so it only matters when you want to be really precise in representation of how the data is formed. In general, and that was much more important when memory was at a premium. Now, like, got gigabytes of memory. Who cares? Just everything's a long floating point uh, double.
hmm
Just store everything with in a million bytes. Like I said, you could earlier. Just go ahead. Uh,
Yeah, it reminds me of using stuff like malloc and
yeah.
demalloc, where you had to
Mhm.
actually allocate the memory for your variable before you put data there. Whereas, like, yeah, people who learn JavaScript, that is like a foreign
Yeah.
language. Like, you would never do that.
Yeah.
I don't think
New
you
and
can.
delete. Yeah. The concepts of new and delete were such a much better abstraction for that than malloc
Hmm
ever was. But again, if you care about really precise way your memory is going, way things are represented. Like when I was dealing with it was for government contract for for avionics software for a helicopter.
Right.
Okay, we wanted to be very precise, and there's not a lot of room there.
Yeah.
Sure, yeah,
I mean, do you think in 2023 this is still important, just less so, or is it just not even really that important anymore?
it is mostly for things where you're trying to like really push the limits of the system. Like I'm sure there are places in game programming where they're really trying to squeeze every cycle out of their CPU and GPU that they're like, okay, we're gonna go full on into this,
Right.
and some encryption. Like when you get really precise math concepts, there's some places there as well.
I gotcha. Okay, so that's pointers. I think the other main primitive type that we can probably just breeze through a little bit is the string idea,
Mm-hmm.
which is generally modeled as an array, which we will get to in the complex types of characters. A character generally is just a single ASCII value, which basically just means like a like a character, a
Yeah,
piece of text.
it's a character that is of a certain size. It's a number that's of a certain size. right? It's like
Right.
an 8-bit unsigned integer that you can store any of these values in it up to like 255, right?
Right.
Um, and then it's how it's interpreted.
Right. And then a string, like the string foo, is like three characters put together. Usually you write it out as just something in quotes, either single or double, or you can write it as an array of characters, like the letter F, the letter O, the letter O. And then it can be later interpreted as just, the string. Obviously, text strings are huge, especially ever since the internet, because really what the internet is just a bunch of computers pushing a bunch of strings across the network. Like HTTP, which is how you get to any web page, is just sending a ton of strings generally across the wire explaining like, hey, this browser wants this page and this page needs this font and these images and this text, and then it sends all that back to your computer and then your browser displays it.
Yeah. Actually, strings are a place where I used pointer arithmetic early on,
Mhm.
like in academia more than anything else, because it is an array, but an array, as we'll get to in a little bit, especially back then, was just a contiguous set of memory,
Mhm.
right? It's all right. I have 4 characters. That's the size of the memory, but that just means 4 bytes, right?
Right.
32-bit. With the caveat that in general, strings are, especially like back in like C days, it's just a pointer that we interpret a certain way. And so a string was really, it's a pointer to the first location in memory, and then it would just read it until it hit a bunch of zeros, right? It's like, oh, there was what was called a null terminator, which was
Mhm.
the character value of 0. There's 8 bits of 0 here, and then you're like, oh, that's the end of the string. And
Mhm.
that's how it was like arrayed in the memory.
Yeah. I do remember that from that C class. I remember making arrays of characters to represent a string. Although now, in most programming languages, you just go, var foo equals open quote your text and close quote, and that's as
Yeah,
far as you ever get in thinking about a
yeah.
string. You know.
Which is all we should really have to think about.
Yeah.
And in fact, you know, character char, right?
Good old
In C
char.
terms, is its own type, and string is specifically an array of characters.
Right.
But in Python, for example, you have no character class or character type. You have string.
Right.
And you might have a 1 character long string, which is what we would think of as a character. So they almost reversed the they flipped the script on that one.
Like, yeah, if you're coming from an older programming language, you want to think simple to complex. So you start with char and then you string
Hmm.
them together to make something. I mean, I guess string in C is really more of a complex data type, whereas in
It
most
is.
programming languages now, people would say that's
It's
a primitive type.
yeah,
Yeah, because
exactly.
everybody uses strings because uh, text and configuration, it's all strings or numbers, and
Yeah.
so why would you need a character type? Because that's a character type is just a single element array essentially
Exactly.
of a letter. So yeah.
Yeah,
Okay.
I think it's important to note that programming languages exist so that humans can take their ideas and make the computer do them, right? And
Right.
they have gotten smarter over the years in that like we can just write it's gotten simpler and simpler to describe what you want the computer to do, to the point
Hmm.
where now we can actually do it in natural language, like with things like ChatGPT and whatnot, and just, hey, give me a this thing, right? And
Right.
okay, sure. But back in the day, it was like when you go to assembly, it was just words representing the memory, and then C was a slight abstraction on that, and it keep pulling back.
No, that's a really good point, and that reminds me that the fact that I wrote down number as a primitive type and not int or integer or float is your point exactly, is that we don't really need two separate data types. We just have number, and the computer is smart enough to kind of understand how to deal with it, whether it's an integer or a float. So
Yep.
Okay, so thank you for listening to this first part one of Data Types and Structures episode of Hacking the Grepson. We'll be back next time where we will go over the complex types of variables. And if you want to get more episodes of our podcast, you can go to hackingthegrepson.com and find our hopefully not basic or primitive episodes that we've done before this. Hopefully they're super complicated and enjoyable. But until next time, we now return you to your regular scheduled lives already in progress.